Welcome to the National Library of Medicine. At this time, it's my pleasure to bring to the microphone the Director of the National Library of Medicine, Dr. Donald A.B. Lindberg.
Well, thank you very much. Now I'm going to give you an authentic welcome. I'm delighted that this event is occurring at all. It's a lot of planning and effort is going into it, and it's a happy day. Thank you for coming. I'm going to be very, very brief in my few introductory remarks, I can assure you of that. And you've got a very wonderful program out ahead of you. Two things I did want to tell you about NLM's contact with Marshall Nirenberg. The first one is that he really was everybody's favorite scientist. He was a really lovely person, and up and down all of the corridors and different offices and echelons and whatnot of the library, lots of people knew him. Lots of people were really pleased and happy with him, and he was, I guess you can't be a favorite Nobelist, but he was a favorite scientist of all sorts. So that said, he proved that on a couple of occasions when I asked him if he could possibly explain to me how he saw the triple codon business. I don't suppose a lot of the symposium today will be given over to the technicalities of that lab work, but I was really more interested in how he even could see the problem. And he very kindly explained it to me thoroughly, well, twice. And I was ashamed to ask for it a third time. But I think I've improved my perception of his wisdom even just by the 2 times. So I think the point of that merely is just to say that to see the problem is really the first big step, and then to have the tenacity to go after the solution. I mean, he knew there was a solution, but also he knew the amount of work that would be involved in getting there. And then thirdly, I think I have to say that kind of work is a tribute also to NIH, because this is not based on a 30-day wonder. This is based on years and years of very careful and determined work, in which I think, as I understand it, colleagues at NIH pitched in and helped, and failing that, stood on the sidelines and applauded his efforts. So you'll get a better picture of him, his family, his achievements, and I guess the science part of it. And maybe we're going to have some writing by a professional writer that will let anybody understand how we got to where he is. So welcome and thank you for being with us. I hope you have a good time. There is a reception after this, which is sponsored by the Friends of the National Library of Medicine, my favorite organization. And if they, well, I don't think you can make them run out of cookies, but it's the intent not to. We'll see how it works out. So welcome to you all. Now, sorry, I should say, my part is also to say that Francis Collins, the director of NIH, would like to be here. He too is an admirer of Marshall Nirenberg. He has to be elsewhere, but he recorded a nice video greetings, and he always says things well, and I hope that you'll enjoy 3-4 minutes of a Francis Collins video.
Good afternoon, and welcome to the National Institutes of Health, NIH, the place that was home to Marshall Nirenberg's pioneering work. I regret that because of a European trip, I can't be with you today to honor this great man's legacy, but let me assure you that I am there with you in spirit. To help understand why there is so much to celebrate today, let's take a quick trip back in time to the early 1960s. Imagine the shockwaves that reverberated through the scientific community in 1961 when a young researcher in Bethesda, Maryland, uncovered the first element of the genetic code, showing that UUU in RNA is translated to phenylalanine. This was the first glimpse of the biological Rosetta Stone. Marshall had begun deciphering the code that allows information in DNA and RNA to be translated into a protein. The news was stunning, The implications profound. It also set people to asking, who was this researcher, this Marshall Nierenberg? For one thing, Marshall was an outsider to the club of the accomplished, whose ranks included many distinguished scientists who'd set their sights on the same challenge. And another thing was clear. Marshall was in it for the long haul. Over the next 4 years, through a lot of creativity and hard work, and the able assistance of a team of colleagues and postdocs, many of whom went on to become international scientific leaders themselves, Marshall proceeded to crack the rest of the genetic code. And true to form, Marshall didn't stop there. Again, working with others at NIH, he set out to determine whether the code he'd found was universal. Was it the language of life? His investigations showed that it was. Darwin could not have imagined the elegant proof that emerged. All life must be descended from a common ancestor. Decades later, when Marshall looked out his window and saw a squirrel sitting in a tree, he paused to reflect. I'm quoting him now. The instructions in the plant and the squirrel are really the same. That's just beautiful. Well, Marshall's discoveries have set the stage for dramatic advances in many areas, including molecular biology, biotechnology, the Human Genome Project, and most recently, the rapidly emerging field of precision medicine. Still, no tribute to Marshall's legacy would be complete without paying tribute to the man himself. Marshall was a scientist's scientist, a mentor's mentor. I was fortunate to know Marshall personally. He was bold and innovative, yet also a great collaborator, and a gentle and modest person. We at NIH are fortunate to have had the direct benefit of Marshall's brilliance and wisdom for more than 5 decades. In fact, it's no exaggeration to say that Marshall Nierenberg, the very first Nobel Prize winner from our intramural program, helped make NIH the amazing place it is today. So it's only fitting that his Nobel medal and certificate will now be on display at NIH in the National Library of Medicine. On behalf of myself and everyone at NIH, I'd like to extend profound and heartfelt thanks to my good friend, Marshall's wife, Dr. Myrna Weissman, for her most generous donation. It is truly a gift for the ages. I send best wishes to all for a memorable symposium in honor of this great man this afternoon. Thank you.
Hi, good afternoon. My name is Jeff Resnick. I'm Chief of the History of Medicine Division here at the National Library of Medicine. I'd like to welcome all of you and thank Dr. Collins and Dr. Lindberg for their time and their support of this wonderful occasion. This is the first of a triplet of collaborative NIH events that will celebrate the legacy of Dr. Marshall Nierenberg and the 50th anniversary of his deciphering of the genetic code. Subsequent events will be announced by the NIH Office of Intramural Research. Today's program is being streamed live globally, and we welcome all of you out there who are joining us here. Following our program, as Dr. Lindberg mentioned, we'll have a reception sponsored by the Friends of the National Library of Medicine, and I also thank them for their generous support. And also there will be a display in the adjacent NLM Visitor Center of Dr. Nierenberg's Nobel Prize medal and certificate, and we look forward to welcoming you there as well. It's now my honor and privilege to introduce our speakers for this special program. Dr. Myrna Weissman is Professor of Epidemiology and Psychiatry at Columbia University's College of Physicians and Surgeons and School of Public Health. She is also Chief of the Department in Clinical Genetic Epidemiology at New York State Psychiatric Institute. Until 1987, she was a professor of psychiatry and epidemiology at Yale University School of Medicine and director of the Depression Research Unit there. From 1979 to 1980, she was a visiting senior scholar at the Institute of Medicine at the National Academies of Science. Dr. Weissman holds a PhD in chronic disease epidemiology from Yale University. Her current research is on epidemiology, detection, treatment, and the genetics of affective and anxiety disorders. Dr. Weissman has been a consultant to many private and public agencies, including the World Health Organization, the White House Office of Science and Technology Policy, the John D. and Catherine T. MacArthur Foundation, and the National Academies of Science. She is the author or a co-author of over 550 scientific articles and chapters and 11 books. She joins us today to offer a remembrance of her husband, Dr. Marshall Nirenberg, and we warmly welcome her for this presentation, and in so doing, we thank her sincerely and publicly for donating to the National Library of Medicine Dr. Nirenberg's Nobel Prize medal and certificate. Let me take the liberty of introducing the rest of our speakers so that you don't have to see me again during the rest of the program until the Q&A, okay? Dr. Frank Portugal is currently Clinical Associate Professor of Biology and Director of the MS in Biotechnology program at the Catholic University of America here in Washington, D.C. He served previously on the scientific staff of the NIH and was a professor at the University of Maryland University College. He also worked in Dr. Nirenberg's lab, as many of you know, from 1967 to 1970. Dr. Portugal joins us today to speak about Marshall Nirenberg. His life is now an open book, based on his own new book, The Least Likely Man, Marshall Nirenberg and the Discovery of the Genetic Code. This book was just published a few weeks ago by MIT Press, so it's a real thrill for us to have Frank here with us today. And earlier today, Dr. Portugal signed copies of his new book at the NIH bookstore in the Clinical Center, so if you don't already have a copy, you can obtain one there. Let me also take this moment to introduce Dr. George Thoma, my colleague here at the NLM, who is Chief of the Communications Engineering Branch of the Lister Hill National Center for Biomedical Communications. This is a research and development division of the National Library of Medicine. In this capacity, Dr. Thoma directs and conducts R&D in mission-critical projects like the automated extraction of bibliographic data from medical articles to populate the Medline database, processing of clinical images such as X-rays, animated virtual books, and a system to aid family reunification in mass disaster events. He's also involved with projects involving multimedia-rich interactive publications. These projects rely on techniques from document image analysis, biomedical image processing, and machine learning. A longtime collaborator with the NLM's History of Medicine division and one who deeply appreciates the NLM's historical collections, Dr. Thoma joins us later this afternoon to launch formally a new Turning the Pages interactive presentation of Dr. Nirenberg's first summary of the genetic code, a copy of which we hold here at the National Library of Medicine and is included in the Profiles in Science online archival collection that we oversee. Concluding our program this afternoon will be Dr. David Serlin, who will speak on curating the code, presenting Marshall Nirenberg in the digital era. Dr. Serlin is a historian and associate professor in the Department of Communication at the University of California, San Diego, where he is also associate professor in the Department of Communication and affiliated faculty in science studies, critical gender studies, and the interdisciplinary group in cognitive science. Dr. Serlin received his doctorate in American Studies from New York University. He's co-author, and editor of numerous publications, one of the most recent of which is a book entitled Imagining Illness, Public Health and Visual Culture, published by the University of Minnesota Press. As curator of the NLM's Profiles in Science site dedicated to Dr. Nirenberg, as well as the new Turning the Pages interactive presentation, Dr. Serlin will offer us a unique view onto Dr. Nirenberg's papers as he has studied them both digitally and in their original analog formats. So thank you to all of our speakers this afternoon. Without any further ado, I welcome Dr. Weissman, and I thank her again for her generosity in ensuring that Dr. Nirenberg's legacy, and now his Nobel Prize medal and certificate, will be preserved here for all time at the National Library of Medicine and made accessible for research, education, and learning. Dr. Weissman.
Thank you, Don, Jeff, all the people who helped today, and all the people over the last number of years who have helped to preserve my husband's legacy. And also thank my family, who helped a great deal, and my friends who are here. This is a remembrance, and it also is about the book that's just come out, which describes from somebody who was right there in the lab, Frank Portugal, what it was like and his view of how the sequences evolved. Marshall was called the least likely man, so I'd like to go through some other least likely men. By the way, Ada, Countess of Lovelace, was Byron's daughter and the first programmer. These are some more least likely men, and you may begin to recognize some of these names. And what did some of these least likely men do? Rather astonishing. They were all least likely men and women who made remarkable innovations which have revolutionized the world. Marshall was also another least likely man. He deciphered the genetic code of life. And I'll tell a story that relates to some of these other least likely men. When Marshall drove from Michigan, University of Michigan, to Bethesda to take his first job at the National Institutes of Health, he arrived in his old car in the middle of the night, and it was 3 a.m., and he said the lights were all ablaze. He was delighted. Marshall had found his California garage. When he realized what he was up against, the great minds, the well-staffed laboratories as competition, his friends and fellow colleagues at NIH joined in to help him to win the race, sometimes giving up some or setting aside their own research. There were some Ida Lovelaces in that group. Maxine Singer, who's quite a famous scientist, Norma Heaton, was with him throughout. This was a competition of minds, ideas, and experiments, but not of ideology or even philosophy. For that, Marshall won the Nobel Prize. Now, you may be wondering, why did we donate the prize? What led up to the donation, and maybe why now? At Marshall's funeral, his sister Joan and I talked about the prize. We kept it displayed openly on a shelf. And she suggested that I donate it after I die. And I said, hey, that is a really good idea. It doesn't belong to me or even our family. It belongs to science. In 2010, in January, after Marshall's death, we began the search for the best place for his papers and how to preserve them. And I found Alan Stipek's name among Marshall's possessions. And I saw that it was in association with giving away some of his papers. And what I also saw in some of the correspondence is that they were really good friends and they shared a lot of conversations together. So we invited Alan, and he has been throughout helping us to make the donation of the prize and all the papers much more possible and much more rational. In 2011, we started to donate the papers. But before that, my children, the Nirenberg family, and later Jim, undertook the sorting of the papers. And we also started to look for the right home for them. Well, I'm an epidemiologist, and I did what an epidemiologist would do. I did a survey of possible places. And I used my time to go around and visit places. I met many curators. I saw where they stored things and how they preserved them. I went to the Smithsonian, the University of Michigan, where Marshall had done his PhD, the American Philosophical Society, where he had become a member, the Jewish Museum in Miami I contacted, and I contacted people at the Weizmann Institute, and various other people along the way who had donated their papers. I thought that the National Library of Medicine, the historical arm of NIH, was the most appropriate place. It was a place where the papers and the medals would be available to the world with the community, using the latest tools actually developed by a lot of other least likely men. And as that has turned out, as we hear about the technology that's been used to preserve these papers and to make them available to the world for a long time, I think that it was the very right decision. In 2013, we donated the medals. There were a lot of medals. The favorite one was the medal that Marshall got from the Vatican. And Marshall was a member of the Pontifical Council. I don't think they give those medals now, but it was a very large medal, very heavy, and when you met the Pope, you were supposed to wear it. When we did meet the Pope, he forgot it. I did call the Vatican, because Marshall told me that the the medal had to go back to the Vatican when he died, and I did contact them, and they didn't seem interested at that point in receiving it back. So it is now at the National Library of Medicine. In 2014, this year, the increasing and astonishing value of the Nobel Prize meant that we could no longer keep it on an open shelf to remind us of Marshall. It was a physical presence of Marshall along with the pictures. The Nuremberg and the Weizmann family, around July 31st, at another event, which also somebody called the 50th anniversary, but it was the 50th anniversary of the genetic code being presented in New York. So this is really the 50th anniversary, which is being celebrated this year. But Brian Clark was quite insistent, and we couldn't, Dolph Hetfel and I couldn't insist that we didn't have an honor for him. So we agreed at that point that Marshall's honor did not belong to one individual or to our family, but to history and to future scholars of science and medicine. And Alan Stipek was very helpful in getting us to do whatever you have to do, and there are things one has to do to donate the Nobel Prize. Now, all the papers and the medals, except two, which I hold on to for the physical presence of Marshall, have been donated. And this is one of them. You saw a picture, it was on the board, of Richard Marsden, Wilbur Cohen, Marshall, and his late wife, Perola, and they were visiting President Johnson. It was right after Marshall won the Nobel Prize. He was the first government official to win a Nobel Prize, and it was a big event, and they were brought over to meet the president and talk about it. Wilbur Cohen, I understand, said, "Marshall, could you tell briefly what you won the prize for?" And Marshall, from his, what he's told me, started to make some very brief statements, and President Johnson, who was in the middle of worries about the Vietnam War and his own election, got up and thanked him very, very much, shook his hand, and went over to his desk. And in a big flurry, and being somewhat upset, he finally picked up this medal and said to and kept the box closed and said to Marshall, "Goodbye, thank you for coming," and whisked him out the door. It is the Chamizal settlement of the U.S.-Mexican border agreement. We still have the medal, and I wonder what the Mexican president thought he won the prize for. There is one other one, and I'm not sure you'll be able to read it, but someday you will. When my children and I, in the last days of cleaning up the numerous boxes which had years and years of uncatalogued memories, we found in a green lab book Perola's diary. And this was a diary that she started October 16th, great day, 7:30 a.m. And she talks about the alarm ringing, and then the telephone ringing, and Marshall getting the call. The book only goes for about 2 weeks, and it so happened that he had won a prize for Columbia University and another prize in Philadelphia, and they had a whole series of events to go to, and it talks about them going to the lab and meeting everybody and drinking champagne, and it's quite touching, and I have yet not given it away. We have it, though, all wrapped in plastic, so it is preserved, and you will get it. Now, the book. We were very supportive of Frank wanting to write a book about Marshall, the first biography, because he was actually in the lab, and he was a scientist, and he would know what it was about. We had no role in the book other than to give names of people and also tell him where he could get the pictures and to give him pictures. And We thought that a first biography written by a scientist who was in the lab would be a great way to begin, and I think it was. I hope it's not the last biography. But I hope this book should encourage young people to follow their curiosity and not to be dazzled or deterred by famous names, famous places, or clubs. And I think that that is, among the other messages, one of the important messages of this book. And I'm also very pleased with some of the reception the book has gotten. And this is from Joe Goldstein, a 1985 Nobel laureate and a postdoc in Marshall's lab. And he says, at least Likely Man engagingly recounts the inside story of how the genetic code was deciphered in the 60s, not by Watson and Crick and their tribe of brilliant molecular biologists, but by the least likely scientist, Marshall Nirenberg, who did the least likely of experiments, filter binding assays. I have no idea what that is. Despite its backwater beginnings, Nirenberg's table of the 64 DNA codons, which we have donated to the Smithsonian because they like those kinds of objects, has achieved iconic status as the biologist's counterpart to Mendelev's periodic table for chemists and Einstein's E equals mc squared for physicists, forming the first holy trinity for science. I thought that was just beautiful. But you know, none of these quotes or the book capture Marshall as a man. And I'd like to end with that. Who was Marshall? He had the curiosity of a brilliant child. He had an incredible imagination, and he was a dreamer, and he really enjoyed other people who were dreamers also. He was a most compassionate human being. He could sit with people and listen to them for hours. He had a complete lack of arrogance or self-aggrandizement. There's a story in the book about Marshall getting a raise of salary at NIH, but doesn't give the backstory. The backstory is that that raise was initiated by NIH. I think they were so embarrassed to have one of their Nobel Prize winners earning such a low salary. And it wasn't that Marshall had asked for one, and in fact it was held back by Marshall because he needed to get 2 letters of reference in order to apply for this salary raise, because he had to go from one title to another title. I've never quite figured out the government titles. And that required 2 letters, and he just put it aside, as he would put aside any things that he considered really not that important. So finally, he did get a raise. Now, you may not know, Marshall was an activist in social justice. He signed many, many letters of importance, and he didn't just sign them, but he helped to craft them. He disappeared from travel, requiring overnight stays for nearly 8 years. People thought he had disappeared from research. He did this so he could take care of his beloved wife, Perla, as she sank deeper into her illness. Since he could not use his frequent flyer miles for traveling, he purchased magazines on boats, and he became quite an expert on boats. And when he met Ron Cohen and Geraldine Cohen, friends of mine, and they had a beautiful boat, one that had been in one of his magazines, he showed himself to be quite an expert and delighted in the fact that he was even given a chance to navigate it by Ron. He loved this, and he said, "This is a good life." He had no children of his own, but he delighted in mine, and in his nieces and his nephews and their children. He watched SpongeBob with Carrie. He brought Rachel a mouse from the lab. That's probably illegal. And then he went to the store with us to buy a cage for the mouse. Sarah, Danny, Noah, Anna lived with him during the summers as he took courses, as they took courses or jobs. He gave lectures in the local public schools, the middle schools and the high schools, because some parents asked him to. He said his vacation to Alaska with our 13 children and grandchildren, including a 2-year-old, was one of his best vacations of his life. It wasn't one of ours. He drove a red convertible, He wore navy shirts and khaki pants. That was his uniform, unless he was forced to wear a suit or a tuck. He was a very deep thinker. And I would like to end with this, and you can feel free to read it yourself, read it out loud, because it's very beautiful. Marshall was a member of the Pontifical Council, and he was invited to the Vatican. We spent a wonderful time with Maxine Singer and her husband there and others. And it was a meeting on, I think, evolution in life, some broad topic. And Marshall gave a talk on the genetic code and evolution. And then there was to be a book from this conference, and he had to write down his paper. And he asked me to read the paper that he had written. And the summary of his paper, I think, is some of the most beautiful scientific poetry I've ever seen. And I asked him if I could type it up and if he would sign it. And this is it. The genetic code appeared very early during biological evolution. All forms of life on Earth use the same or very similar genetic codes. All forms of life on Earth descended from a common ancestor, and thus all forms of life on this planet are related to one another. The molecular language is used to solve the problem of biological time. It's easier to construct a new organism than it is to repair an aging, malfunctioning one. The messages in DNA that we inherit from parents contain wisdom gradually accumulated over billions of years. The messages slowly change with time, but the translation of the language remains essentially the same. I want to end by saying, I began by saying there was a book, The Least Likely Man. But I want to end by saying that if you really knew Marshall, you would realize he was the most likely man to unravel the code of life. Thank you.
I'm looking for the remote control. Let's see it here. Okay. Okay, well, good afternoon. Jeff, thank you very much for inviting me to this symposium. It's a thrill to have a chance to talk about Marshall, and an honor to be invited to participate in this session. As you've heard, I've written a book about Marshall. The title of my talk now is Marshall Nirenberg is now his life is an open book. Hopefully some of you will open it and have a chance to look at it. And I wanted to try to construct my talk today both about Marshall's life and about his scientific work, but to do it somewhat in the context of books, because we're here at this wonderful National Library of Medicine, where I spent a large amount of time researching and writing the book on Marshall, which I'll explain a little bit later in the talk. But I also, some 38 years ago, was here, and I'm sorry I'm dating myself. I was here to write a first book, which was called The Century of DNA. And as I did with the book on Marshall, both books were researched in the History of Medicine division, and was very, very important to be able to accomplish writing both of those books. I thought that since we're in the National Library of Medicine, to try to have some analogy with books, I would try to be appropriate. Now, first of all, I want to point out that Marshall has in his hand a cigarette. So at some point in his life, Marshall was a smoker. And he came to NIH, as Myrna mentioned. And I want to tell you a quick story before I get into the books related to Marshall's work. So the story takes place in the 1960s. And the United States is involved in two wars. It's involved in the Cold War, and it's involved in the Vietnam War. And Marshall's invited to give a talk on the code in Washington, which he does. And when he's finished, a strikingly beautiful young woman comes up to him, which was not a surprise, because in the pictures that you've seen of Marshall, he actually is a quite handsome man. And she says with a slight accent that she would like to invite him to lunch. And Marshall says, why? And she says with her slight accent, I'm deeply interested in the code, and I'd like to learn as much about it as possible. And she sees that Marshall is sort of a bit reluctant to follow up on this. And so she adds, and after lunch, we can get a hotel room. And so Marshall, very generously but very quietly, demurs. But that's not the end of the story. Sometime later, Marshall learned more about this strikingly beautiful young woman who had come up to him. It turned out she worked for the Russian embassy. She was a Russian spy. And when she heard that he was talking on a code, she thought it had significant military value. And she just did not appreciate that it was a genetic code. So I think that's one of the hazards of doing work at this level. Many of you may know that Marshall's story is very dramatic, not just on the science part of it, but in terms of his personal biography. And when he was 10 years old, living in New York City as a result of a prank, he was pushed into a pool of water in the wintertime, and he ran home. And at that time, that sort of event could lead, which it did in his case, to rheumatic fever. And rheumatic fever could damage your heart. And so Marshall's father moved the entire family out of New York City to what was considered a more rural part of New York, which was slightly north of New York City, Westchester County. And this is a picture of, not of Mount Vernon, where they actually moved to, but of a location very close to Mount Vernon, because I couldn't find the picture of Mount Vernon in 1937. This is White Plains. But it gives you an idea that there was some infrastructure. It wasn't a totally rural environment, but it was, from a New York perspective, considered the country. Now, we're talking about 1937, where the Great Depression is winding down, but it's still in effect. So a move to even out of New York City is not something done lightly. And I was very interested in learning as much as I could about Marshall's father, because I felt that, to a large extent, the father serves as a role model for the son, and that perhaps I could get some insights into Marshall's character and his motivations and his behaviors by understanding more about his father. And what I learned was that his father was quite intelligent. He had gone to Cornell and then had got early admission to Cornell Medical School. But after a year and a half, he dropped out of school. He dropped out of medical school for reasons which we don't know, because the letter he wrote to the school explaining has been lost in the archives. But he dropped out of medical school to enroll in the Army because the First World War was going on. He was in for a 3-year duration, but the armistice a few months later ended his service. But he didn't return to medical school. And I thought perhaps there's a little bit of a sense of impulsivity there. After living in Mount Vernon for a year, his father, Marshall's father, Harry Nirenberg, moves the family from New York to Florida, to Orlando, Florida, which I'll talk a little bit more about in a minute. And his father is an upper-class New Yorker, has lived all of his life in New York. He's obviously very intelligent, has gone partially through medical school. And the move to Orlando is a significant change, but then one would think, well, he'll go into something that he knows about. He was an executive in the shirt manufacturing business. The South produces textiles. Perhaps he'll set up a company to manufacture shirts. Perhaps he'll set up a retail store to sell clothing. But he doesn't do any of that. He becomes a dairy farmer. He knows nothing about dairy farming, which is one of the hardest types of farming because you have a herd of animals that require constant attention 24/7. There's a lot of hard physical work involved. There are complications because of the milk industry. And so he makes this move, which again seems to be, to some extent, a little bit of an impulsive situation. And I mention this because when Marshall came to NIH, and when he decided to segue from carbohydrate transfer in cancer cells to working on protein synthesis in the genetic code, several people cautioned him that to work on a problem that was considered one of the most difficult in the 20th century at the start of your career was really very dangerous, that it could really have had disastrous results. And so I wonder to some extent if there was a little bit of impulsivity in Marshall's deciding to do that. And so that's, in a sense, a little bit how I connected Marshall and his father. So this is New York City in 1937. It's already a very sophisticated place with skyscrapers, a large amount of humanity that I say passed over the sidewalks of New York like a river flowing over its bed. It was just a mass of individuals and a mass of humanity. This is the Orlando, in a sense, that they came to. This is an undated photograph. It's probably a bit earlier than 1937. Notice the wildlife, the alligator. But this is what they transferred from New York to Orlando, Florida. For the family, the results were somewhat disastrous. Earning a living became much harder. Marshall went to the University of Florida because his family could not afford to send him to a private school. And for Marshall, though, it was a tremendous event that was very positive because it awakened in him a tremendous love of biology, which Myrna has referred to, a love of science, and it made it possible for him to really invest in that. So this is an example, Marshall with a snake. There were swamps and woodlands all around. He lived in a very rural part of Orlando. He liked to capture snakes, put them in a bag, hide them under his bed. His mother knew nothing about it. She came into his room one time and said, "What is that terrible smell?" Marshall said, "No, I don't smell anything." And hastily, when he could, took the bag of snakes, took it out of the house, and released the snakes back into the wild. But he also used this time to develop a relationship with the American Museum of Natural History in New York. And what he did is he collected specimens of spiders and insects and sent them to New York. They provided him with a small amount of resources to be able to do that. And that was sort of his early foray into biology, into research, something that he really could not have done had he remained in New York City. So this is Orlando as we think of Orlando today. It's a fun and fantasy place, a happy place, a place where you bring your family, a place to have a good time. This is the Orlando of 1937, when the Nuremberg family arrived there. Orlando was the seat of power in the state of Florida for the Ku Klux Klan, which is portrayed here. The Ku Klux Klan didn't like Jews. Marshall's family was Jewish. They didn't like blacks or African Americans, and they didn't like Catholics. In fact, there were very few things that they did like. So there were lynchings, there were shootings, there was a custard stand that would serve both blacks and whites, so it wasn't separate but equal, which was dynamited. Marshall, as far as I know, Marshall's family, although they lived on a farm in a rural part in the outskirts of town, was never directly affected by the Ku Klux Klan, but you can imagine they're living in this type of environment. So when Myrna referred to Marshall's very strong sense of social consciousness, which he displayed throughout his life, at least a portion of it comes from his experience living in this environment, which in a way was ironic because Marshall's ancestors had come from Eastern Europe. And they had come not so much because they thought the streets of New York were paved with gold, but because there was such rampant anti-Semitism in Eastern Europe, in the towns and cities where they lived, that they feared for their life. So the irony is that their descendants, Marshall's family, is now living in an area dominated to a large extent by the Ku Klux Klan. And this not only affected Marshall, this affected his sister Joan, who was 2 years older than Marshall, who went to the University of Alabama. She couldn't get into the University of Florida because they didn't admit women, and later ended up living in Mississippi, where she became very, very active in the civil rights movement, which could have been extremely dangerous to her personal safety. This is NIH when Marshall first came here. Myrna told you the story of when he first came with the lights on. He was ecstatic. But when he found out that the lights did not mean that scientists were working late, but that cleaning crews were coming in because the scientists had left at 5 o'clock, that was a disappointment. But he had a number of other disappointments right from the very beginning at NIH. One was that his mentor, DeWitt Stetton, would go in the summer and spend the summer at Woods Hole. And that was something that he did routinely throughout the years. The problem is that when Marshall came at the beginning of the summer in '57, Stetton had failed to inform him that he would be away. And so Marshall had a disappointment in finding that his mentor wasn't there to help him get started. Marshall also, in a way that was a positive, because Marshall displayed a tremendous interest in being an independent investigator as soon as he got out of his graduate program. Stetton did not want him to be an independent investigator, and so there was a conflict of concern over that. And so Marshall had a couple of these disappointments that could have, to some extent, with a person who would be more easily affected by this, who might have lacked the sort of self-confidence that Marshall inwardly had, although he didn't necessarily speak about it or display it, might have easily derailed a career. And Marshall not only managed to get through that, but as we know, and as we'll find out a little bit more, really achieved tremendous accomplishments. This is a picture of Marshall and his first postdoctoral student, Heinrich Mattei. There was only a 2-year separation between the two, and that eventually caused some difficulties because Mattei certainly felt that they were sufficiently close in terms of age and training that they should be treated perhaps more as equals. Now, Marshall and Mattei made an interesting finding, a very important finding, it turned out, in terms of how Marshall's scientific work progressed. And that is that there was a quandary, there were two quandaries in science. One quandary was that the genetic material, DNA, in a cell is located in a particular part of the cell called the nucleus. And it doesn't come out of the nucleus. It stays there. It's protected in the nucleus. But protein synthesis occurs distant from the nucleus, outside the nucleus, in the periphery of the cell, on a structure called ribosomes. And one of the quandaries was, how does DNA direct the synthesis of proteins if they're physically apart. And so the idea was a thought that perhaps somehow portions of the DNA are copied, sort of like a copy machine, so that the original instructions, the DNA, does not leave and does not get damaged, but copies can come out, can go back in, can be destroyed, new copies can be made. And so there was the idea, a hypothetical idea, that there could be a messenger, some form of a material similar to DNA, a material called RNA, that could come out, could be transported to the ribosomes, and could direct protein synthesis there. And actually, let me go back here and show this. So these are the ribosomes. So this was known in 1957, but this was not known and this was not known. So this is what's called soluble RNA. It transports the building blocks for the proteins, which are called amino acids. It transports that to the ribosome, and then this is the messenger RNA, which has the instructions and directs which amino acid goes in what sequence to form a particular protein. So Marshall and Mathai isolated ribosomes, washed them, not with soap and water or a washcloth, but in a scientific sense, and found that there was a small amount of RNA that came out, which was not soluble RNA, and which they recognized was likely to be the messenger RNA. So Marshall realized that you could isolate ribosomes, you could remove the messenger. If you did that, if you had the messenger and the ribosomes together with the soluble RNA, they would make protein. If you took out the messenger, the ribosomes couldn't make protein anymore because the instructions were no longer there. If you put the messenger back, protein synthesis would start again. So Marshall had a very simple but brilliant idea. If you could take the messenger off the ribosomes and put it back on, why couldn't you take the messenger off the ribosomes and put something back on which was different? And so that became a very important concept that eventually led to the famous PolyU experiment and the use of a synthetic messenger, which contained only the unit U, and that made a protein that contained only one building block, which was essentially phenylalanine. So this is a book by Malcolm Gladwell, which I think has some relevance to Marshall's story in two ways. First of all, Gladwell talks about an underdog who prevails by using their status to surprise and accomplish things. And to some extent, I think from people I talked to and indications I got back, to some extent, Marshall was considered, certainly early on, an underdog in terms of solving the genetic code issue. But I think he used his status as an underdog to surprise and accomplish things that were really unexpected, particularly by people he was competing with. Gladwell also points out that it's not necessary to go to an Ivy League school, that sometimes you're better off being a big fish in a small pond than being a little fish in a big pond. And that, to some extent, also relates to Marshall's education. He went to the University of Florida, which was certainly, even for a land-grant college, not a particularly outstanding place. He got his undergraduate degree there. He got his master's degree there. He went to the University of Michigan, which at the time, the Department of Biochemistry was so anxious to have students that they were really admitting students with very little analysis of whether they were appropriate or could really succeed. And of course, Marshall did succeed. Now, I was fortunate too in not only trying to learn about Harry Nirenberg, but also trying to learn about Marshall in the various life stages that preceded his coming to NIH. And I was fortunate to find someone who knew him when he was in elementary school, several people who, friends who he had when he was in high school and who I was able to speak with, some people who knew him when he was in a fraternity at the University of Florida, several people who knew him when he was in graduate school. And I think the thing that emerges from those conversations, and that's in the book, is that Marshall throughout his life actually had this wonderful persona that Myrnis described, this modesty, and it never changed. He was like that from early on all the way through his entire life. This book by James Case seeks to try to put competition on a very scientific basis. And he uses some of the mathematics of John von Neumann and John Nash. John Nash was the subject of the movie A Beautiful Mind, and uses game theory to try to put a scientific basis to competition. Now, Marshall faced enormous competition in his work on the genetic code. And Marshall was really the David in the David and Goliath story. The Goliath was a group of 20 of perhaps the world's most outstanding scientists at the time that banded together to form a group called the RNA Tie Club. And this club restricted its membership to the original 20. Marshall, although he was working on the same problem that the RNA Tie Club was working on, could not gain any entrance. And so he faced that competition. Then he went to New York, and he met with Severo Ochoa, who was a Nobel laureate. And Ochoa was also trying to solve the genetic code. And Marshall wanted to collaborate with Ochoa because Marshall wanted collaboration, but really did not like competition, did not feel that he'd ever been in a situation where he had to compete, and therefore he was uncomfortable with it. And Ochoa said, no, why would I? Although he didn't say so, essentially, why would I want to compete? You're a government scientist. You're just recently out of graduate school. I'm a Nobel laureate. Why would I collaborate with you? Now, he didn't actually say that, but I'm sort of reading into it a bit. So Marshall came back to NIH very depressed and very concerned and realized that he had two choices. He could either step aside or he could choose to compete. And we know what happened with that choice. So the National Library of Medicine has Marshall's papers. Part of those papers are these green hardbound notebooks into which Marshall, from the moment he arrived at NIH essentially, jotted down his ideas, his thoughts, his concerns, the names of people that he wanted to read their papers or wanted to talk to. And it's these notebooks which really form the basis of my trying to track and understand how the scientific work occurred. So I didn't want to simply write a chronology of Marshall's life or a chronology of his scientific work. What I wanted to do is get behind that chronology and say, how did this all come about? What was the line of thinking? What was the reasoning? What was the logic or the illogic, if that was necessary, that made this happen, made this possible, that this man came up with this concept and was able to prove it? And so the National Library of Medicine and the History of Medicine Division was very important because these books are actually not kept here on site, but in Baltimore. And so when I wanted to review them, they had to be transported down from Baltimore. And that went very smoothly, and I'm very appreciative of the fact that we never had a problem about it. Now, this is considered a classic in molecular biology. This is a book by Horace Judson. And Judson came to NIH when he was writing this book to interview Marshall. And Marshall told me this story. So Judson, who was an American but had lived in London for a number of years, as a arts and science correspondent for Time magazine, had a particular view on who really deserved credit for the genetic code. And it wasn't Marshall. And I'll explain this in the next few slides. And Marshall said to him, well, I have these notebooks which will show you which are dated and which show you the evolution of the ideas, and from that you can surmise that, in fact, the credit that I received was really accurate. And Judson not only turned down Marshall's offer to look at those notebooks, which I've used to construct an entire book, but also to some extent was insulting to Marshall, suggesting to some extent that the notebooks couldn't be validated or it would be difficult to believe. And Marshall was very, very upset by Judson's comments and appearance. And Bob Olby, more recently, wrote a book on Francis Crick. And in this book, and I'll tell you in a minute why this is important, in this book there's a chapter of about 26 pages which talks about how Francis Crick, who won a Nobel Prize with Jim Watson for working out the structure of DNA, how Francis Crick discovered the genetic code. This is a picture of Marshall receiving the Nobel Prize for discovery of the genetic code from the King of Sweden. He was a co-recipient with Bob Holly and Gobin Khorana. And so you would think, having won the Nobel Prize, that that's the end of the story. That's international validation that of all the people that could be credited with that discovery, Marshall Nirenberg was the appropriate person. 38 years later, in 2006, this book was published, supported by the Alfred P. Sloan Foundation, a very well-respected foundation in New York City, in a program that they have called Public Understanding of Science. Now, I used a textbook at the University of Maryland on that had a chapter on molecular biology, and in that textbook, Francis Crick was credited as the discoverer of the genetic code. There was no mention of Marshall's name. Now, how the publication of a book like this enhances public understanding of science is something I have struggled with for many years and can't fully explain. And then we have Sidney Brenner, who also was a Nobel laureate. Crick and Brenner were part of the RNA Tie Club that Marshall was competing with. Brenner won the Nobel Prize for working out genetic development of worms, nematodes essentially. Brenner came to Columbia University in 2013 to give a distinguished lecture, the Cartwright Lecture. And the title of his talk was The Last 60 Years of Molecular Biology. Now, you would think somewhere in the last 60 years of molecular biology, one Nobel laureate would be able to parse and indicate that another Nobel laureate, Marshall Nirenberg, deserves some credit. But from my understanding, although I didn't attend the lecture, my understanding was that Marshall's name was not mentioned. So now we have a couple of examples. We have Horace Judson's book, we have the Ridley book, we have the Olby book. So the question is, what's going on? So many people believe that Marshall's obscurity as a seminal scientist of the 20th century in resolving the genetic code problem came from his incredible modesty and unassuming character. But these types of situations, these publications, suggest that perhaps the situation is a bit more complex than simply Marshall's personality. And I have a theory about this, and what I think is that there's an enormous difference in viewing priority between European scientists and scientists in this country, and I think this is reflected in the patent policies of the two areas. And let me explain. So in Europe, to get a patent, if you have an idea or a concept, you can apply for a patent. You don't have to show that that idea or concept has any real validity. You don't have to physically embody that idea or concept, you can apply for the patent. Up to very recently, in the United States, it was the complete opposite. In the United States, if you have an idea or a concept, you cannot patent it. You have to do what they call reduction to practice. We're a very pragmatic nation. It's not just ideas and concepts. We want things that actually work. And so the test is that if you have an idea or a concept, you have to make a physical embodiment of that idea or concept with instructions that someone else can follow and can repeat in order to even apply for the patent. And so I think that perhaps this explains why the RNA Tie Club and members like Crick and Brenner and Judson's book give credit not to Marshall and Mattei for the discovery of messenger RNA, not to Marshall for the discovery of the genetic code, but to European investigators like Sidney Brenner, who was from South Africa, but then spent a lot of time in England, Francois Jacot, who claimed to discover the messenger RNA, was from France, and from Francis Crick, who is from Great Britain. So I think it's this dichotomy of views that if I'm European, I have an idea or a concept, therefore it has validity. And in America, we say, no, if you have an idea or a concept, you reduce it to the 64 triplets and identify the function of each of those triplets, and that gives you validity. So I think there's the dichotomy which has, in part, really obscured Marshall's place in the pantheon of notable scientists, particularly in molecular biology in the 20th century. This picture comes from an event which forms the last chapter in the book, and it's an indication of Marshall as a man, his generosity together with Myrna Weissman's generosity. Marshall assembled together all of the associates, all of the postdocs who had not only helped him on the genetic code, but had been part of his career at all the time that he spent at NIH. And we had a wonderful celebration at the Cosmos Club in Washington, D.C. And it's an example of the type of person that Marshall was, that how he would think of others, particularly at a time when he really had a great need to think about his own interests and his own concerns. So we're talking about Marshall's discovery of the genetic code, but that happened starting in 1961, and a lot has happened in science since then, and I just wanted to show this slide. So there's a field of biology called biotechnology, and biotechnology is both discoveries of how life works in molecular biology, as well as the translation of those discoveries into practical applications. I know about this because I direct the master's program in biotechnology at the Catholic University of America, and as part of the field of biotechnology is a separate part called synthetic biology. So synthetic biology seeks to genetically engineer and improve on how life functions, and one of the things that synthetic biologists have done now is that they have synthesized new nucleotides, which are the building blocks of DNA, been able to incorporate that into the genetic material, and as a result of that, we now have expanded the code from the natural process, which consists of 64 triplets that can code for only 20 amino acids, to a situation now where we can potentially code for 172 amino acids. And so the idea behind that is if you can create enzymes or proteins which do not naturally occur in nature, that perhaps they'll have applications in medicine or in industry so that you can actually direct an organism to make a particular protein for a particular application, as opposed to having to search living organisms and hoping that you will eventually find that out. Now, several mentions have been made about Marshall's medal and the generosity of Myrna Weissman for providing that medal for the National Library of Medicine. A Nobel medal is what we call an intangible asset. It's like a patent in that it's very hard to evaluate monetarily what that metal is worth, other than the material that it's made out of. However, quite recently, that situation changed. Jim Watson, who with Francis Crick, discovered the double helical structure of DNA, found it necessary to put his metal up for bid. And there was a winning bid. So we now have an intangible asset which now has a stated value. And the stated value for Watson's metal was $4.7 million. And, very typical perhaps of Jim Watson, he got the metal back from the bidder who felt that he should still retain it. So we have an idea when we talk about generosity, there's generosity and there's generosity, and we're talking about close to a $5 million donation, theoretically, to the library. So let me go back to that. So I was very fortunate to be in Marshall's lab. It was an experience that changed my life. I got credibility from that experience way beyond anything I deserved, but rather the mantle for Marshall fell on all of us who participated with him, fairly or unfairly. Of course, eventually we had to go out and prove that there was some substance to that. I just want to end on one or two notes. My editor at MIT Press came to Washington. We had never met. And one of the first things he said to me, he said, Frank, it's been 38 years since you published your first book, A Century of DNA, to your second book. How long will it take you to write your next one? I said, 38 years. So if you choose to read the book has a window on Amazon.com. You can go to Amazon.com to books and put in the title of the book. And you have an opportunity to write a review. You can write the review anonymously. And I would encourage those of you who decide to read the book to try to do that, because those reviews will give greater visibility to Marshall and will encourage other people to perhaps read the book and to write their own reviews. So between my book on Marshall and my next book, you have a very wide window of opportunity. And so thank you very much.
Hello. Thank you. Good afternoon. This occasion is notable for me on at least two grounds. First, a celebration of an NIH colleague in this joyful way, personally thrilling. But secondly, it's an opportunity to talk about a product we created in his honor that I think gives an idea of how scientific discovery happens. Oops. And rather than a single aha moment, many people have said that probably more often than not, it's a gradual evolution from a first fundamental principle to the next step and the next idea, and so on. So this point is well made by a recent book by Kevin Ashton, a professor at MIT. The book has the inspired title, How to Fly a Horse, The Secret History of Creation, Invention, and Discovery. And Professor Ashton debunks several myths about creativity. One, that Einstein cracked the theory of relativity while chatting with a friend. No. In reality, Einstein worked for several years on his most famous theory. And Wassily Kandinsky did not walk up to a canvas and create his magnificent painting with white border in a single afternoon. Didn't happen that way at all. In fact, he spent months planning his spontaneous painting, even creating a whole lot of preliminary sketches. Now, coming back to the chart, the sequence of steps in Dr. Nirenberg's scientific discovery is not readily apparent to scientists who are not in the immediate field, and much less to lay people, even intelligent and educated lay people. And here's where two things come in. One, a good curator who knows the science and the scientist, and the other, appropriate technology. So with the excellent curation provided by David Serlin, and with our software powering the virtual chart that you'll see, I think we have a tool to help at understanding how Dr. Nirenberg's seminal ideas took shape, and perhaps offering a glimpse of the scientific brain at work. So before I get to how we made the electronic chart, as Jeff said, it is part of our Turning the Pages collection, along with interactive virtual versions of several historic books at the library. Here's a partial list. This, for example, is the first zoological book by Conrad Gessner in the 16th century. And this is the classical book on human anatomy by Andreas Vesalius, also in the 16th century. Of the Edwin Smith Papyrus, the oldest surviving surgical text from 1700 BC, and named after the American collector and collector of antiquities, who acquired this, the original from in Egypt in the 19th century. So Michael was instrumental in convincing the New York Academy of Medicine, the owners of the chart, or the papyrus, that the world would be better off with a virtual scroll that one could touch and unroll and study curators' notes, as you see here, or translations of the surgical cases from the original hieratic script. It's a form of cursive Egyptian hieroglyphics, and also zoom into any part of the papyrus with this virtual magnifying glass. So all of these treasures can be seen here at the, it can be seen, studied, and played with on touchscreen monitors here at NLM in kiosks, also as web versions at this link, and as at Dr. Lindbergh's suggestion, inspired suggestion, as an iPad app. So thank you, Dr. Lindbergh. I'll first briefly review the Turning the Pages project, how it came about, and the technology developed to make these virtual books. And then I'll show why we had to come up with a new approach and new technology to make Dr. Nirenberg's virtual chart. So in the summer of 2000, urged by Ken Smith, who was the NLM's deputy director at the time, I took a trip to the British Library to look at a system he had seen on one of his visits there. And he said that it allowed users a neat way to interact with digitized books. They called it Turning the Pages, and you could touch and turn these beautiful illustrated pages. You see the Lindisfarne Gospels here, for example, and there were other treasures like the Diamond Sutra of Sanskrit verses, and several other equally historic objects, books and volumes. So I was accompanied by Joe Fitzgerald, the enormously talented artist, now retired, but then at the Lister Hill Center's audiovisual program development branch. And obviously, we couldn't possibly turn down a trip to enjoy the mild and crisp summer in London. We had just escaped from a muggy summer in Washington. And here we are, two government workers working hard on the National Library of Medicine's behalf. But our goal was to understand the technologies the British Library was using and perhaps negotiate for their software that we could then use to create a similar system here for rare medical books. Well, though our hosts were most welcoming and unfailingly genial, I was unable to persuade them to reveal much about the technology. And we're not at all blaming anyone for this, since later we learned that they had worked with a contractor in London to create the software, and there might have been proprietary issues that got in the way. But the British Library did help us with our first book, Elizabeth Blackwell's Curious Herbal, published 1739. They did help us animate this book. It's a beautifully illustrated book of medicinal plants, and for that we remain grateful. Anyway, on our return, a group of us sat down, analyzed the problem, investigated and developed a computer model for an electronic book. A computer model meaning translating the physical parameters of a book into a mathematical construct, and then designed the software, the animation software from scratch. And then we came up with a touch-sensitive system that we installed in 2 kiosks here at the library, and one is right above us on the floor above in our visitor center. Additional software was subsequently developed to expand Turning the Pages to a website, as well as to create the iPad app, as I mentioned. And Mike Chung, my colleague, was the principal developer of most of this software and continues to improve it and to add more books to this collection. And the iPad app was built by Mike in collaboration with Dr. Alex Karagiris, one of our postdoctoral research fellows, and also he's a computer engineer. Now, people seem to like these virtual books. More than 10,000 unique visitors come to the website every month, and about 4 million page views. The app has been downloaded by thousands of people on their iPads. The kiosks are visited by lots of library patrons and are a favorite spot for busloads of school children who visit NLM periodically. So how is the virtual book made? I'll briefly describe this to contrast it later with what we had to do for the virtual chart. So there are several steps in creating these virtual books. And the first step is to scan each page at a very high resolution and 8 to 10,000 pixels in each dimension with a color bit depth of 24 bits per pixel or greater to capture fine detail and the subtle grayscale or color variations of the book. This is, as you can probably recognize, a page out of Conrad Gessner's book in zoology. And now the images are then processed to remove page edge effects and bordering and distortions. These are resulting from the scanning operation, and they have to be removed. and basically we have to end up with a page that can serve as a texture onto a computer model. Then we built the model, and the model actually is a combination of a model for the cover of a book as well as the pages. And these items, pages in particular, are imported into this tool, and it's a tool called Maya. And Maya allows the computer engineer to animate the pages and also to select, there are many options, to select the right lighting model. Now, in the earlier books, we used in Maya a one bulb, so-called one bulb lighting model that cast somewhat harsh shadows. But now we used something like a global illumination model that allows the shadow of a page to vary in darkness as it's turned. The effect is softer and more realistic as far as shadows go. And if you compare these two pictures on the right, you can see that the one on the right creates a shadow as the page is turned that you don't see on the left. Then finally, the final stage is to import the Maya software into an interactive software development environment called Director. And in this, it actually is built by Adobe. And in this environment, we develop the code to sequence the pages and to enable the user to interact with the touchscreen system. So what's different about the virtual chart, and what did we have to do to that? So in contrast to the virtual book and the virtual papyrus, using the chart, we quickly realized, does not require any animation, but rather the need to drill down or dive deeply into a large image. So we had to rethink our approach in this case, and we decided to develop the virtual chart as we would an online map. Think Google Maps. And this approach would let the user zoom deeply into the chart and pan over it, as well as interact with clickable regions, to invoke text or photographs and other images. So right after the original is scanned, and we do this at a pretty high resolution, 12,000 by 10,000 pixels, we use an open source software called MapTiler. And MapTiler divides the digital image into tiles at different magnification levels, different zoom levels, and all of these are stored. And all of these levels now go into a folder structure that can be operated on by any of several mapping libraries, like Google Maps, Yahoo Maps, OpenStreetMaps, or Leaflet. And we chose Leaflet. It's an open source JavaScript library that enables interaction with a map like panning and zooming, and also provides overlay boxes that can be used to implement navigation, put in text, and it also allows interaction hotspots to be included on the surface here. So the interactive areas of the chart are polygons drawn onto the chart by specifying coordinates. We then add our own JavaScript code to invoke sliding panels like this, and that contain curators' text. And then we add hyperlinks that you see here to link these areas to photographs, other images, PDFs, external websites, and the like. So at the end of the day, what we have is a virtual chart based partly on our own code and partly on open source software. That's tools that are available freely to anyone. And we did all of this in close collaboration with our collaborators in HMD, Jeff Resnick, Christy Moffett, and last but not least, David Serling, who's the curator every step of the way. So now I'll turn this over to David Serling, curator extraordinaire.
Thank you, George, and thanks to everyone who made this event possible, or I should say this first of the triplets that will be taking place over the next, over the year. I want to thank Jeff for inviting me today, to Donald Lindberg for helping to make this possible. I want to thank my colleagues in the Digital Manuscripts Program, Christy Moffett and Susan Speaker, and the amazing staff that help preserve the materials that I'm going to be speaking about today, and Michael Chung for his software expertise. And then just finally, I want to thank Myrna and Frank and George for not only their presentations today, but also because, conveniently for me, the last speaker on the roster, they've kind of a setup for me, everything that I want to talk about today. Partly about my interactions with Marshall Nirenberg, not as a postdoc in his lab or as a colleague or coworker, but as the historian assigned to help make sense of the materials that he donated to the National Library of Medicine, to Frank for helping set up some of the biographical material, and also for doing a brilliant job of explaining the kind of scientific significance of what Marshall Nirenberg was able to accomplish in his time from the late 50s, early 60s to the final chart, which I'm going to also speak about today, which was revealed in 1965 and 66 as well. And then also to George for kind of giving us an overview of what it means to take something like this. I think I've got this is not a very clear copy of the summary chart that is now been digitized and made available on the Turning the Pages site that George was described. But of course, it is the one of the major objects of 20th century science, up there with E equals MC squared and the Crick and Watson model of the DNA helix. I want to go backwards, though, to my title, which I call Curating the Code, because I want to say something about what it means to curate materials in a collection. Curating is not the same thing as writing a book. It's not the same thing as preserving documents. It's not the same thing as going to a scientist's laboratory and begging sometimes for them to release the materials so that you can bring it into the library and accession it as part of the library's collections. It's none of those things, and yet it sort of combines all of those things. To curate means to make deliberate decisions about what you believe in your own capacity you want to share with the public. And that's, I think, a very important part of what the Turning the Pages project is about, is making choices about how to not only show materials to the public, but then also how to annotate them, how to make them accessible. It's not just enough, I think, to scan a lot of documents and put them up as PDFs and say, here you go, everyone, this is you can make your own way through it. Well, there are elements of that in terms of making things accessible, but curating means to, as I say, not only make deliberate choices, but to kind of guide a reader, a viewer, a user by the hand, and to help walk them through what is important. And I would say that in the case of Marshall Nirenberg, curating his project, curating the Turning the Pages project, but as well as the other project that I was involved with in the early 2000s, meant curating the work of a scientist who was a devoted public scientist. This is something that all three speakers today have referred to, that not only was Marshall Nirenberg an extremely modest man, but he was someone who was very much committed to being a public scientist. You can imagine that in the early to mid-60s, and then of course following his Nobel Prize in 1968, he was made offers from virtually every academic institution as well as private corporations all over the world who said, if this is what you can do, please come do it for us. And he said no. The NIH is a unique institution, but it's also a way that I am able to connect my work as a private citizen with the work of helping to facilitate and make possible public science and make that publicly available to the people. So that was a very important part of his commitment to the work that he did as well as the institution that he was dedicated to. So before I was given the great honor of curating the Turning the Pages project that George described, I worked on a project that is here in the National Library of Medicine that's part of what's called our digital manuscript program. This is a page from Profiles in Science. Profiles in Science started in the late 1980s as a project of the former director of Lister Hill, Alexa McRae, in collaboration with the National Library of Medicine. And the idea behind Profiles in Science, as you can imagine, was to find scientists, hopefully those who were still active or at least still around, and ask them about whether or not they would be interested in having their scientific papers and even some of their personal papers brought into the library to be preserved as part of the library's modern manuscripts collection. And in 2000, I, as a sort of postdoctoral / historian in residence at the National Library of Medicine, I was brought in to take on as my next project the papers of Marshall Nirenberg. I'd worked on a couple of other profiles of scientists like Martin Rodbell and Krista Anfinson and also Barbara McClintock, whose papers are at the American Philosophical Society in Philadelphia. But all three of those scientists had passed away or had been dead for quite a while. Marshall Nirenberg, however, was still alive and kicking in 1999 and 2000 when I was given this assignment. And so I want you to imagine what it would be like to go visit a scientist who at that point had been working at the NIH for 40 years, who at that point had said, I am willing to allow you to come to my laboratory, I'm willing to allow you to come to my private home, and if there are papers that you would like to bring, or materials I should say, that you would like to bring and absorb into the collections, I open the gates. And open them he did. And I think it's important to keep this in mind because typically when a historian is asked to curate a collection, he or she goes to a collection that's been already figured out. It has a finding aid. It's all been processed. All the materials have been neatly categorized and they've been gingerly put into mylar sleeves and into envelopes and into folders. They're color coordinated or they are alphabetized. None of these things were in place when I was, and Christy Moffett and other members of the Digital Manuscripts program, when we were assigned to bring at least the first amount of materials that Dr. Nirenberg was interested in giving to us to absorb into the collection. We went to his beautiful mid-century modern house in Bethesda, which I understand has since been torn down, and we went into the basement and we found something akin to the final scene of Raiders of the Lost Ark. And if I describe to you a basement that I think at one point had been a playroom or had at one point been an area to play ping pong, maybe stretching from here to this wall, that was nothing but boxes. Boxes that Marshall Nirenberg had used to collect every bit of paper, every bit of information, every product catalog that had ever come across his desk. and he had saved it all. And that had nothing to do with the collections of materials that he had in his office upstairs. The amount of material that he had in his office alone was so much that they had to install pylons underneath the floor to support the amount of paper that had been accumulated over 40 years in that office. And this is, of course, a completely separate set of materials from those that he had in his laboratory office on the NIH campus. So my colleagues in the digital manuscript program and I, we went as if we were going on a dig. And dig we did. And among the amazing amount of materials that Dr. Nirenberg kept and preserved along all the receipts and the airline tickets and the product catalogs. If you were ever interested in what laboratory catalogs for laboratory equipment looked like in 1965, this was a very nice collection to have. Among all of those things, we found absolute gems, things that he didn't even know about, things that he had certainly forgotten about. And one thing that I kind of want to emphasize, and I think this came about in some of the comments we've heard earlier, is that Dr. Nirenberg was not a scientist who thought of his time as precious or thought that we were rummaging around in his basement and he could be sort of left to his own, his own work. He made himself available through the whole process. He made himself available when I showed him objects like this. This is the original draft of the speech that he delivered in Moscow in 1961 to a standing room only crowd of 1,000 scientists when he first announced the PolyU experiments sort of in a big public forum, the published article of which would appear a little bit later in proceedings of the National Academy of Sciences. What you have here is a scientist who's obviously has a typed draft, but he's working through his ideas. And he's adding, he's subtracting, he's doing what historians and maybe lay scientists alike love to see, which is how someone organizes their thoughts, how they present those thoughts, and then how that gets translated into a final typed manuscript. This is what historians think of as the mother lode, the gold treasure that we all are seeking out. Because for a historian like Frank, who wants to unravel the backstory and not just look at the final published articles, these are invaluable annotations onto the story that we think that we know. So I found, and my colleagues in Digital Manuscript Program, we found tons of things like this. We found lots of photographs, some of which we've already seen. We found the original photograph. This is a photograph from 1962 that was done where Dr. Nirenberg and Heinrich Mattei, his postdoctoral student slash collaborator, they were asked to do this photograph as a sort of a press photo where they would write on a pane of glass kind of to dramatize the sort of spectacular work that they were doing. Along the way, in processing through these materials and gathering them, I had a bit of a panic attack. And the panic attack had to do with the time frame in which the Profiles in Science site needed to go up. Typically, archivists and historians and librarians, they get to settle with a lot of these materials. They sit with them for a while. They get to put them in boxes, categorize them, alphabetize them. And once everything is kind of neat and clean and organized, then they plunge in to the process of creating, in this case, a website that has all these materials available. But that was not the case for me. As we were bringing things into the library, we were instantly coding them, we were turning them into PDF files, and that was the beginning of what turned into a 6-month process where we were basically bringing things in 1 week, scanning them the next, and within a very short amount of time created this online exhibition. So if you go to Profiles health.nlm.nih.gov, you will see all of the profiles in science, and now there are just a ton of materials related both to lab scientists as well as scientific organizations and a whole range of things relevant to the history of medicine and history of 20th century science. This is just one page of what I created, which was a curated overview of Marshall Nirenberg's work at that point. And so you can see that I've broken it into these different categories: biographical, the first period where he was working with synthetic RNA and the PolyU experiments, and then translating the Code of Life, public reactions to the genetic code, which could be a whole book unto itself, an amazing assortment of both profound and insane responses to the code by the public and journalists, and then later work, which many people don't really know about in terms of the transition that Dr. Nirenberg made away from specifically focusing on the code and then working in all these other areas, neurobiology, neuroblastoma research, homeobox genes, and then referencing something that Myrna had said, his commitment to social justice issues as a scientist who often used his profile to do political advocacy work or band it together with other scientists to make public statements about things that they saw were unjust. So this is what my job as a curator has been, is to select items, put them into some kind of framework, and then make them available to the public so that you can go onto the website, go to any of these links, and it will take you to a narrative, it will take you to documents, it will take you to visuals. I wanted to share some of those with you. Obviously, we've looked at this one. Frank showed this picture. I have to admit, I've looked at this picture about 100 times, and I've never seen the cigarette in his hand. So just goes to show you can always learn something new. I think the important point here is that this was yet another press photo that was taken in 1962, and what you see across from him underneath the blackboard are just dozens of balls that he would then use to try to imagine the different combinations for the codes. And I think it's really important that this photograph be kind of circulated because it shows that this is an interest and a kind of obsession that Dr. Nirenberg kept at for that whole period of the mid-1960s. So for example, when we were going through his files at his house, we often found pieces of paper like this. What are these? Obviously, this is someone who is trying to sketch out, make connections, figure out the triplets, looking at all the different letter combinations. This was written on a scrap piece of paper. This is not written in one of the kind of formal NIH notebooks. This is something that for a lot of scientists, as well as probably for a lot of people, might have gotten tossed away. This is, again, a piece of treasure for us to kind of think about how the mental processes are at work. One of my favorite items that we found was similar to this one, but in a kind of slightly different context. This is a page from an artist's catalog, and there was an artist showing in Bethesda, Marina Nunez del Prado, an artist. And this is the front page of the catalog for her art. What do you see here is I have this fantasy of Dr. Nirenberg saying to Perola, will you excuse me a second? I just need to go over here in the corner and I gotta get some ideas out. And he's scrawled very similar combinations onto this page. Again, something that for another scientist or in another context might have just been tossed away. Or the art catalog might have found its way into some bookshelf, never to be recovered. But because of Dr. Nirenberg's capacity for preserving things, even things that he didn't see in the moment to be, for posterity, with kind of vision for the future, these things were all saved, and they are all part of that legacy. Among the many things that we found going through the files were beautiful photographs. And again, these are photographs that were taken not for the press, maybe just as snapshots for friends and colleagues. I think there are a number of people in this room who are represented in this photograph. You see Dr. Nuremberg there, and directly to his left, his late wife, Parola. But it's an image of, I think, the kind of excitement, enthusiasm, and youth of NIH scientists during that period. This is another piece of the puzzle, and I think it directly relates to the talk that Frank gave earlier. This is the original draft of the speech that Dr. Nuremberg gave when he accepted his Nobel Prize. It was written on a scrap piece of paper, shoved in between lots of layers of other things. And to be able to have this, as well as the typed version of it, allows us to toggle back and forth between the ideas that he was gathering, as well as the ideas that then became formalized. By the way, if you look at the very top of the page there, you'll see the phrase Belt 1. For those of you who are old enough to remember a time when people did dictation and they referred to dictation recording technologies as belts as opposed to tapes, then you'll have some awareness of that this is a piece of media history as much as it is a piece of scientific history. Before I move on, this is actually a photograph of the session where Dr. Nuremberg and Parola met with Lyndon Johnson. And Lyndon Johnson is doing his kind of famous lean in to Parola and Marshall, which he was apparently famous for doing, I don't think to intimidate this particular pair, but to kind of show that he was in fact listening. This is, I think, just before he gave them the medal for the U.S.-Mexican Water Treaty. I think he's on his way to his desk. Dr. Nuremberg shifted gears after being awarded the Nobel Prize in 1968, and I love this photograph. Again, something that we found sort of buried in a box with a whole bunch of other things. It was used for promotional material a little bit later on, in the late 1960s. But one of the things I like about it too is it really does show the evolution of scientific work and laboratory work at the NIH. That is absolute state-of-the-art computer equipment behind him. Probably all of that could fit into something smaller than his watch now. But I think these are the kinds of documents, the kinds of artifacts that scientists love, historians love to be able to see, so that we get a better sense of the science and the technology behind the activity. So all of the materials for the Profiles in Science site were launched in 2000. So we had a very limited amount of time to gather materials and to create the site, Profiles site that I showed you earlier. In 2007, the NLM was able to finally put together and release the finding aid for the Marshall-Nuremberg papers, a collection of papers that obviously Frank is quite familiar with, and it is well organized. You can use it. The finding aid is online, and if you are interested in his life and career, I highly recommend you taking a look at it. But it did take a while for that massive material to be put together into some kind of usable form. And as we've heard today from Myrna and Frank and George, those materials still keep coming in. And that's because we continue to find materials, and people who were affiliated with Dr. Nuremberg, and even after his passing, those materials come to light and they get absorbed into the National Library of Medicine's collections, and those collections are obviously preserved for posterity. So what I'd like to do just with the remaining time is I'd like to talk a little bit about the Turning the Pages project. In the Profiles in Science site, I had a limited amount of time to put together and curate a presentation that tried to give a flavor for the breadth of Dr. Nirenberg's career, from his early work through his work on homeobox genes and into the latter part of his career before his death in 2010. And that has been updated several times since it went live in 2001 or in 2000. When I was asked to curate the Turning the Pages site for the final chart, which you see here, I had the luxury of not having to account for someone's 50-year career, but instead being able to focus on one discrete object. And so there is an interesting trade-off that happens when you are asked to talk about someone's life in a big, in a kind of big way, in a big presentation. Sometimes you can skip around, you can summarize, you can move from kind of shallow description to slightly less shallow description in the interest of kind of moving things along. But for the Turning the Pages project, I was given the opportunity to really focus on this object. So what I'd like to do is I'd like to switch to a live feed of the, can I just go from here? Or someone's going to do it for me? Click on that. Okay, clicking. Okay. And I'm going to go directly to the Turning the Pages site. Now, George mentioned that this site will be turned into an app for the iPad so that you can use it in that kind of interactive way. But you can also access it now. It went live on the web about a week ago. And so this is basically what you'll find if you go to this address. This is called the first summary chart because what you have here is a very high resolution scan of the first summary of by Nirenberg and his team that accounts for the deciphering, if you will, of the codons for the 20 amino acids. I'm not going to walk through every single element here, but just to say that the different sections here, I'm going to just go like that so you see where I am on this page that's full of a lot of data. The introduction is obviously here, and it will take you to different areas. This is a section called Before the Code, where I've provided a kind of historical account of what was going on in both science as well as sort of socially and politically to kind of give a sense of the urgency of the race to decipher the code. There's a section on breaking the code, celebrating the code, and then preserving the code. And what George was referring to here is if you go to any one of these sections, you can zoom in and look at all of the notations that are available here. You can go as far back or as close as you want to the material so that if you are so inclined, you can see the calculations and all of the evidence that was sort of then demonstrated here and preserved here. The last thing I want to just say a bit is something about preserving the code. We are in a place in history where many of the materials that scientists and, for that matter, artists are using in laboratories or in their studios are materials that are everyday materials. These are materials that we use when we scribble something with a ballpoint pen, or when we write something on a piece of paper that might be a crumpled napkin, or the back of a matchbook cover, or in the era of email and digital communication. We're dealing now with materials that were not meant to be held onto or are not meant to live for posterity in ways that papyrus scrolls or other kinds of materials have actually withstood the test of time. So if you look at the preserving the code section, it will give you a little bit of information here about why that's so important. If you look at the section here that I'm kind of pointing to with the cursor, there are materials here that are literally degrading and are falling apart as we speak. This chart was made long before Excel spreadsheets existed. They were made of multiple pieces of graph paper that were taped together with Scotch tape, scrawled on with ballpoint pen or with red pencil, a lead graphite pencil itself. These are not materials that are going to withstand centuries of preservation unless we take an active role in trying to hang on to them. So part of the interesting struggle and challenge of documenting, preserving, and curating 20th century science, like that of Nuremberg's summary code, is how do you keep this for future generations? You can obviously make great scans of it, you can make beautiful photographs of it, you can make as many facsimiles as you want, but the actual needs to be preserved in some way and conserved for future generations. So there were a number of conservators here at the NLM, Holly Hero among them, with whom I worked in trying to figure out not only how to present this amazing document, one of the great documents of 20th century science, but also how to think about the ways that it exists as an artifact in the world. Scanning a document is one thing. Thinking about how it's going to live on for future generations is entirely something of a different magnitude. So I think I want to just end there by encouraging you to take a look both at the Turning the Pages site as well as the original profile site and see about how science is something that we have a kind of collective investment in as a community and as a nation as well, to try to hang on to, not just in terms of describing them or writing books about them, all of which are important, but also how to kind of think about them as very precious objects in which sort of our future posterity is held. Thank you.
Thank you very much, David. Why don't we have our speakers come to the front? We have about 25 minutes for a panel discussion. We'll take some questions and provide some answers, and we'll have some discussion. If anyone would like to depart early, please go right ahead, but we hope you'd stay with us. And those of you who are online, please stay with us and listen in. Why don't we take our first question here? I will say this is an unplanned moment. If there's anyone listening through the webcast that wants to email me a question or tweet me a question, I'll have my iPhone with me here, and I can orchestrate that. Unplanned, but we'll give it a go. How about any questions from folks here in the audience? Yes, sir. Please use the microphone in front of you. Oh, right, you're looking for Meredith. Go ahead. Any questions? Very good. Just use the microphone in front of you so we can pick up your audio. Thank you.
This question is for Dr. Portugal. When you were referring to the origination of ideas with European scientists as them seeing themselves taking precedence over the coding idea, so was it just they thought, oh, well, maybe there's a message and that makes protein, like, is that where they thought, oh, I figured it out? Like, what happened between where they claim credit and where Dr. Nuremberg figured out the code?
Oh, press the button, okay. There really are, I think, two phases. One is documentation, that this private club had discussions among its members, theoretical. The club actually had a very strong theoretical bent, which to some extent was why they failed, because the code had to be really discovered experimentally and not theoretically. But they had a lot of theoretical discussions of which they could document but never published. So this is a group which is apart from the general function of science, where generally in science we share information, we discuss progress, we learn from each other, but this was kept very separate. So using that documentation is the basis on which they proceeded. Now, in the case of Messenger, Watson and Crick and Jacob and Brenner did actually publish 2 papers in Nature on messenger RNA. What they did is they showed it that some material was coming out of the nucleus that was labeled. So it wasn't solely a physical demonstration. The problem is that when you're going to choose for priority unpublished materials and documentation, items written on pieces of scrap paper, as David was talking about, that becomes very difficult to really identify priority. And what I did is I said, and what Judson didn't do, is I said, who published first? Because that's in a peer-reviewed journal. And it was Marshall and Mattei several months before the 2 papers by members of the RNA Tie Club appeared. But as I was trying to say, the Europeans, I think, go back to the correspondence that they had among themselves to say we discovered it first. And I say, no, I think Marshall discovered it first because he demonstrated that it wasn't just a concept or an idea, that it was a physical, tangible type of material. Does that answer your question? Okay.
Janet, you have a question?
Hi, actually a question for anyone. Probably David, you might be able to discuss, but was Dr. Nirenberg aware of the synthesis of additional triplets and the possibilities of what could come from that, things that had never been imagined in biology, essentially?
I don't know the question of that. Most of the work that I did with and most of the interactions I had with Dr. Nirenberg was really in the early 2000s and very briefly in the mid-2000s. So I really don't know, and it's not a subject that we ever discussed. Maybe that's Frank.
Was anyone else aware of him being aware of that synthesis occurring? Or the possibility of synthesis?
I'm not sure I follow. You're talking about the what I was talking about in biotechnology with the additional material.
The additional materials. He originally had 24, and then you brought it up to
64.
72.
He had
64, and then 272 was the final number, I think.
Well, it's 172 amino acids.
Okay, right.
It's only about six additional. It was a total of 6 nucleotides, but because there's sort of an exponential combination to that, it could code for 172. Marshall had, I believe, and Myrna can possibly help me with this, close association with, for example, Craig Venter. And Craig, who competed with NIH on elucidation of the human genome, also has been in the forefront of synthetic biology. He took a mycoplasma organism, took out its genetic instructions, chemically synthesized an entirely new set of instructions, inserted it back in the cell, and then the question was, would the cell behave as it did originally, or would it follow the new set of instructions? And it followed the new set of instructions. So I think his association with Craig Venter to some extent would certainly possibly have kept him abreast of new developments.
Marshall kept up with this very, very keenly, intensively. He had journals that were stacked all the way up, and he read them. He read them every day. He also kept up with people like Cam Smith and Craig Venter and others. And I think one of the last things he wrote was a preface to a book on recoding. And he had some thoughts about that and responded to a book which was at the forefront of the next stage.
I suspect he was very excited by that possibility.
Oh, yes, yes, of course. But he was working on other things. He was working on, he felt, when he changed his career after he won the Nobel Prize, he went into neurobiology because he thought maybe you could find a code there. He said it was much more difficult. And other scientists who've won Nobel Prizes have gone into neurobiology and had the same experience. And he was working with robots, and he was using different assays to try to figure out drugs that would help. He was the one that worked out the mechanism of morphine, and then left it because he took it as far as he could. But with robots, he could begin to figure out some compounds that would would do what morphine did without the addiction. And he was working with Shail Sharma in India. In fact, they were writing a paper on that when he died. So he never gave up thinking of new ways and also following the science.
Questions? Yes, sir.
Yeah, this is, I guess, a question for maybe either Dr. Portugal or Dr. Weissman. I was just wondering, after Dr. Nirenberg continued working at NIH in his lab after receiving the Nobel Prize, of course, and I wondered, Dr. Weissman, you mentioned that he kind of shifted focus into neurobiology, but how did things in his lab change as far as the people that he was working with? Were there any noticeable changes after winning the Nobel Prize, or did he just kind of go back to business as usual?
Well, you knew him. I can only say hearsay.
In academia, you would have an opportunity to mentor students for a PhD degree, for example. And if in the course of your career you would mentor 25 people, that would be a large number. Marshall mentored 150 postdoctoral students and did so throughout his entire career. So despite the fact that he was at NIH, which is a government laboratory, he was more active throughout his career in terms of academic activities like that than he would have been had he been at essentially an academic institution where he would have had to serve on committees, he would have had to do institutional building, also all sorts of things that would have taken him away from his research, which he loved, and which, to a large extent, he hated to have anything interfere with, really. Does that answer your question? Or?
Yes, I think so. Thank you very much.
Well, also, laboratories are made up of postdocs. They're not senior. It's not like a European where you have a senior professor who tells people who are a little bit younger what to do. These are postdocs, and they come and go. So as Marshall's research evolved into neurobiology, he got a different kind of postdoc who were interested in that. But the story was that he told me, and I think others, is that he did a lot of traveling after he won the Nobel Prize, because Nobel Prize winners travel. But then he decided he wanted to do something different because it would no longer be as exciting to work on the code or to work on things that were derivative from the code. So he gave up his laboratory to Tom Caskey. Actually, Maxine Singer's here. She probably knows the story better than I do. And Tom took it over, became a very famous scientist and one of the vice presidents at Merck, and I think is now at Baylor doing research. And he spent several years learning neurobiology and then started working there.
Can I just speak to that? One of the most amazing aspects of going through Dr. Nirenberg's papers, at least the kind of initial gathering of the materials that we did in 2000, was that he saved letters that he received from people all over the world every kind of letter, from congratulatory letters to fascinating letters, some of which I was going to share with you today, but they are definitely on the profile site. And there would be occasional letters from high school and college students who, and this is in 62, 63, when he was very busy working on the code, and they would say things like, I would really like to come to your lab and talk to you. And we have the response letters, because he dictated them, and so there was a carbon copy of them, and they all said, please come to my lab. I'd be more than happy to show you around the lab and answer your questions. And one of the college-age young women who wrote to him eventually became a postdoc in his lab, Zandra Brickfield. So the amount of public outreach that he did and the amount of response that he had. He was not sort of living in a secluded or ivory tower mentality where he only did his work. He was very much in the role of a public scientist, and I think that was very important to him.
Other questions? Yes, sir.
Yes, this has to do with emails have been much in the news recently in a political sense. So when you're curating a corpus that includes emails or even traditional printed letters or handwritten letters, how do you balance the correspondents who may not have given permission to have their addresses or the email addresses exposed versus the desire to show this to the public?
Well, I can't speak to the present situation, nor would I want to. But what I will say is that when a scientist or anyone signs what's called a deed of gift, that means that the materials that are in their personal possession, they become part of the donation, and they become part of the institution to which they've been donated. If a person has private or controversial materials, and he or she doesn't take them out before they're donated to the library, then the library or an archive has a responsibility to think at least about what it would mean to make this available or to make it turn it into a PDF and put it on the website. So there are certain ethical questions that any archivist, or in my case a historian, has to ask. So for example, if there is someone who's donated his or her papers and there are materials in there about a marriage or a divorce or children, something of that nature, and the person who signed the deed of gift or the estate did not say, take that out, what does one do with it? And so these are questions that archivists have to think about all the time. And there was nothing of that nature in Dr. Nirenberg's papers, as far as I could tell. The questions are not about the kind of ethical, personal stuff, but more how much material do you scan every notebook, every page of every notebook that Marshall Nirenberg ever put a pen to? No. If you want to look at those materials, you're more than welcome to. But what the job of a curator is to think about those materials that would be most useful and make selections of them. It doesn't mean that I or the project has put up everything, but we've put up what we think are a really good selection. But as far as things that might be of personal or political, there are people who have donated their papers and they've been embroiled in all kinds of political intrigues and so forth. Libraries have protocols about things like that, and very often they're put into what's I think commonly called deep storage. For example, a family might say, could you put that into storage for 50 or 100 years until all relevant parties have passed away? And most libraries, including NLM, respect that.
Thanks.
We have a question up here.
Yeah, I just wanted to follow up on what David said. The Society of American Archivists and the various historical professional organizations have long-standing standards and different levels of access and such. Some of you may remember a few years ago when Thurgood Marshall died and his papers were made public, people were quite surprised that he had everything opened immediately because he wanted that effect to make something brighter. Here at the National Library of Medicine, we occasionally get papers that have personal patient information. We are not a HIPAA-covered entity, but the History of Medicine Division has standards to preserve the privacy that people deserve and expect when they go into a personal relationship with a physician or scientist.
Yes, go right ahead.
Hi, thank you for your time and all of your anecdotes. I was wondering, why do you think that Dr. Nirenberg keeps being left out of being credited with his own discovery of the genetic code?
Well, as I tried to show in my talk, books that are written, talks that are given, either omit his name or gloss over it, fail to give him the proper amount of credit. And so someone like Francis Crick, who was just almost to a large extent the opposite of Marshall in terms of personality. He was very outgoing. He was very aggressive. In fact, I talk about some interactions between Crick and Marshall in the book, and also compare their careers after the discovery and awarding of the Nobel Prize for the genetic code. They both went into neurobiology, and the outcomes, I think, are really quite significant, where they had to essentially work on their own as opposed to having young people help them. I thought to say, I mean, this almost sounds silly. When I started the book, I was aware of this discrepancy, and I thought, and I asked several people, is it possible that NIH or the federal government could actually have affected the awarding of a Nobel Prize to someone in the intramural program? Because I knew from my time here that Congress has routinely looked into the intramural program at NIH, concerned that it, to a large extent, duplicates the external program. And so for NIH to have a Nobel Prize winner would certainly counter that argument very effectively. But several people I talked to said that they thought it was absolutely impossible for the federal government to exert that type of leverage. So I really think that it's really the difference in perspective, but the problem is that it's gone on for such a long time. This book, the Ridley book, was published in 2006. It's 38 years after the awarding the Nobel Prize. So there's some animosity that seems to continue, and I think to some extent there's probably a feeling among some of the members of the RNA Tie Club that they, in fact, deserved, at a minimum, to share the Nobel Prize with Marshall. And that's it.
Just want to add, though, as a footnote, it really didn't bother Marshall. I think that it bothers some of us now that he's gone because we don't want him forgotten. But it really didn't bother him. In fact, he thought it was sort of funny.
I think the tension between intramural and extramural support has been around for a long, long time, and it's entirely possible that some of the motivation for the books that Frank mentioned might be rooted in that kind of a tension. You know, the feeling that from the outside looking in, the intramural science may not be the same kind of scrutiny. For instance, people here don't have to constantly apply for NSF grants or NIH grants to continue their work. They do have to appear for the boards of scientific counselors, but that's a whole other thing. But I think the answer to your question cannot be truly answered, I don't think. We're all speculating as to why the tone of those books are the way they are.
Yes, sir. And then Madam. Or Madam, sir.
I thought it might be interesting to just say a little bit about what it was like to come to the NIH to work in the late 50s, early 60s. It was not the obvious choice of ambitious young scientists because it did not have the stature that you would get if you went to a university and had the word professor in front of your name. So many people chose not to come here. Marshall was one of those who did. And that choice itself is an interesting one. I don't know whether Frank Portugal has been able to shed any historical light on that decision, but it was an unusual decision for the time. what many people didn't appreciate is that there were a lot of young people coming and that they made a group that was both talented and effective.
Can I just say something? The person who just spoke was Dr. Maxine Singer, who worked with Leon Heppel and was very instrumental in producing material that Marshall needed for his experiments. She, along with another Nobel laureate, Paul Berg, also have written a book on not Edward Tatum, who was his George Beadle. Just wanted to mention that.
Hey, Jeff,
Yes, Dr. Lindberg.
I'd like to make a coda to Dr. Maxine's remarks about choosing to come to NIH. I once was sitting on a bar stool next to Jim Shannon, which was a very good way to talk to him, actually. And I said, Dr. Shannon, you left P&S to come to NIH because he commanded a chronic disease branch. And I said, did you ask Dr. Lerb when you were going to depart for his advice? And he said, sure I did. I said, what did he tell you? He said, Jim, you'll never be heard of again.
A lot of people had that.
It combined, first of all, leaving Manhattan, which was insane in itself, and then going to the south, and then going into a government lab. Well, you'll never be heard of again. But he was.
There are a number of people who had that experience, and were given that same advice, possibly from the same person or from different people. In response to the issue about how Marshall came to NIH, he was actually sent here by his mentor at the University of Michigan, who felt that Marshall needed more experience to learn methods. So he came here to learn how to do science, basically.
Going back to the question as to why Marshall didn't receive the thing, and Frank's response in part about Crick's very large ego, which was absolutely true. The story is very much more complex, because while it's true that Marshall gave a talk at the Moscow conference in '61 to an enormously large group, it was after, and only after, he had given that talk to about 8 people in a tiny room, and it was Francis Crick who said, you got to hear this, people. Judson, I think, had something to do with it, and there's lots of other reasons for it.
So you should know that this is Bob Martin, who was another member of the group of people at NIH who volunteered to help Marshall out and advance the work very rapidly.
Let's take 2 more questions before we enjoy our reception. Any? Yes, ma'am? Back there. Yes, sir. Sorry, I can't see you. The lights are too bright. Yes.
I'm Radharaman Ray. I was one of Marshall's postdoc, and I heard some of the questions, particularly one was what Marshall did in the neurobiology field. And I think it is very appropriate to have a little comment on that, because it's a tribute to him, and we are mostly talking about his genetic code work, which turned out to be to the end. It went to the end. But we are here about 6 or 7 that belong to the neurobiology group. And just give you a simple example, like in the genetic code, what he did, he more or less deciphered how the codons dictate the incorporation of amino acids into the proteins, right? So in the neurobiology function, he was working on the similar area, and his assay was a functional assay, like how the neurons establish synaptic contact and how they become functional, or how is the cell lineage recognized in the development of the nervous system. So he had a whole bunch of collection of neuroblastoma cells and hybrid cells with all different kinds of properties that dictate either formation of synapse or some synaptic function like acetylcholine release function. So he was looking into some of the determining factors that more or less control that, one of them being the voltage-gated calcium channel. And I was working on that area with him, and one evening he called me to his room, and he told me that I was not working hard enough, and he said, aren't you excited that we are working on the synaptic code instead of the genetic code? So that more or less gives a little flavor of what he was doing in the neurobiology. As Marna pointed out, one notable report was the morphine. That is very useful information. And then in his lab, we started the ion channels. Sodium channel is one, and calcium channel is the other. And one of his very able students, Bill Catterall, has done almost Nobel Prize winning work in the voltage-gated channel works. So basically, that's the kind of important work was going on.
Can I ask you a question?
Yes.
Were those neuroblastoma cells the one patent that Marshall had?
I am not aware of that.
Okay. Thank you.
Let's take one more question, if we could. Anyone? Yes, sir.
Frank, could you just tell us a little bit about the other two people who shared the Nobel Prize with Dr. Nirenberg?
Well, there were two people. One was Robert Holley. Holley worked out the structure, the first structure for the soluble RNA that I showed in the diagram of the ribosomes and the messenger. And that gave some insight into how a particular type of soluble RNA could recognize a particular amino acid, because there's a great deal of specificity. And then also, how could that complex recognize the particular code word on the message? So Holley, for having worked out the structure of that, I think it was alanine transRNA, was awarded. And Khurana took a different approach. What he did is, he was basically a chemist. He synthesized units of DNA, knew the exact sequence of the building blocks in the DNA that he synthesized, transcribed it into RNA, had the RNA translate into protein, and so was able to make very specific identifications. Before Marshall developed the triplet assay, which I think, David, did you have? Yeah. Before Marshall developed what was called the triplet assay, the thought was to use long messages, polynucleotides. The polynucleotide of all U's gives phenylalanine. That was very straightforward. When you wanted to do the other 63 triplets, it became much more complicated. So what they did is they made messages where they mixed the building blocks together to make the message. The problem was, when they did that, they got translation, they got specific amino acids incorporated, but they had no way to know the exact sequence of the message. So Khurana's approach turned out to be very helpful, because he knew the exact sequence by synthesizing the DNA.
Jeff, I know we're running out of time, but I hope I won't embarrass them by, we have two people here who were absolutely instrumental in the early 60s lab that Nirenberg ran. Norma and Teresa, could you just wave your hands? This is Norma Heaton, Teresa, check. Who, and many of the photographs that you'll find on the Profiles in Science site that show the lab. Sorry?
She did some of those.
Yeah, yeah. And so it's rare to have people who are part of this kind of extended community at a tribute event. So in addition to scientists like Maxine and others who were there, we have a whole range of people who are either on the campus or have been affiliated on the campus for a long time, who really contributed to this kind of extraordinary work. So thank you.
Thanks indeed. And thanks to everybody for participating today. Thanks to all of you for being here this afternoon, for all of you who listened in remotely. I want to thank our 4 speakers who did a wonderful job. Thank you all very much, and all that you each and together have contributed to this program and to the work that you've done. I want to thank also Dr. Lindberg for his support of this, certainly also Dr. Collins for his introductory remarks, and the entire team of people here at NLM who've come together to make this event possible in all divisions across the library. I'm grateful. We're all grateful. And thank you all again. And please join us for a reception sponsored by the Friends of the National Library of Medicine just beyond this wall in our lobby. And check out the display of Dr. Nirenberg's Nobel Prize medal and certificate in the NLM Visitor Center. Thank you all very much. Thank you.
That was really good.
Thank you.
We'll have to keep pushing the book.